All right, last lesson of chapter 10. We're going to talk about some trig ratios. I know those who had Dr. LaFollette have already, or I know that you ladies have already heard of the trig ratios and probably worked with them. So I'm going to try not to spend too much time. So we have the following trig ratios. I'm going to let me label my triangle real quick. We're going to label it A, B, and C. So when we have the angles here, that is our viewpoint. Like that's the side of the triangle we're standing at, and then where things are based off of that. So where we have sine of A, this is our focal point. So we read it sine of A, but we write it sin, and then just the A next to it. We don't have to put the angle symbol or anything. Cosine is cos, and tangent is tan. And so that's how we write our functions for sine, cosine, and tangent. And then our definition. So real quick before we go, actually, we'll go ahead and just write into this. I understand I didn't leave enough room in this to write really big. But for sine, we're doing opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. And the easy way I remember this is I always wrote, even now I'll write at the top of my paper, so, ka, toa. And so that's sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Just a way to help me remember. Now, how do we know what's opposite and what's adjacent? Hypotenuse is always across from that right angle. That one is always hypotenuse. But it matters what angle we're looking from. So since we're at A, this leg here is my adjacent leg, because it is next to the angle I'm working with, whereas the leg clear over here, this is my opposite leg, because it is on the opposite side of the triangle. So when we get into examples like this one here, and we're wanting to write all the ratios for angle, and in this case, again, we're going with A. So here's angle A. I know that this side here, that's my adjacent. And then when I draw my arrow to the opposite side, this is my opposite. And then, of course, this is hypotenuse. So from here, I'm going to do sine A equals, and then sine is opposite, so 15 over hypotenuse, 17. And then cosine of A is going to be adjacent, so that would be 8 over hypotenuse, which is 17. And then tangent of angle A is going to be opposite, which is 15 over adjacent, which is 8. And that is how we write our trig functions for our angle. Now, if I were to write them for angle B, I would do sine of B, but they would flip-flop, right? For B, if I'm looking here, this one is my adjacent, and over here is my opposite. And so for sine B, we would be 8 over 17. My hypotenuse never changed. Cosine of B will be 15 over 17, and tangent B just is the reciprocal, 8 over 15, because we're now opposite over adjacent. So that's why it matters what angle you are working from, because that adjusts your adjacent and your opposite. All right, and then in the calculator, we need to type this, when we want to find the value, we're going to type it into the calculator. So I'm going to go pull up my calculator and I'll be right back. All right, so we are going to find the cosine of 55 degrees. We want to go to the nearest 10,000. So on the calculator, which I have, but of course in presenter mode, it doesn't want to pop up. And this is on your handheld calculators as well. You have your sine, cosine, tangent. You want to make sure that you're in degree mode. So if you're not sure, feel free to ask and I'll help make sure that you are in degree mode. And then you just hit cosine 55. And then that gives us our decimal. Thousandths is 3, so 10,000ths is 4. So we want 4 decimal places. So in this case, the 1, 2, 3, 5 is my fourth one. The 7 changes the 5 to a 6. So then when I go back to type in, or to write my answer, my cosine of 55 is going to be approximately, because there were still a whole bunch of decimals afterwards, 0.573, and then again, that 5 becomes a 6. And that is our approximate value of that calculation. All right, in the next video, we're actually going to use sine, cosine, and tangent to help us find missing sides and or angles. And so I will see you there.